everyone, welcome back to my YouTube channel. Hi, this is Netra from CSC Data Science 3rd Sim. Today I'm dealing with the subjects math and our topic is a joint probability distribution for two discrete random variables and the expectation value, covariance and the correlations. Now, the topic is a joint probability distribution, which means these are the probability distributions that describes the relationship between two or more random variables. A joint probability specifies the probability of each possible combination of values for a random variables. The joint probability density functions, that is PDF, for two continuous random variables x and y is denoted as f of x, y, while for two discrete random variables x and y, it is denoted as p of capital X is equals to x and p of y is equals to y. Now, the expectation value of joint probability distributions, which means in the probability theory, the expectation value in a joint probability distribution function represents the average value of a random variable or a function of a multiple random variables. It's calculated by summing the product of each possible outcomes and its probability. And the covariance. In joint probability distribution, covariance measures how two random variables changes together. It quantifies the degree of which the two variables tends to deviate from their respective means in the similar way. A positive covariance indicates that when one variable is above, it means the other trends to be above its mean as well, while a negative covariance indicates the opposite to a positive covariance. A covariance of 0 suggests no linear relationship between the variables, but it doesn't necessarily mean that they are independent. Next, a correlation. In a joint probability distribution, correlations measures the strength of direction of a linear relationship between the two random variables, that is x and y. It is a scaled version of covariance where the correlation value ranges from -1 to 1 and the midpoint is zero point 0.1, which refers to a 90 degree. A correlation of 1 indicates a perfect positive linear relationship and -1 indicates a perfect negative linear relationship and 0 indicates no linear relationship which has a constant value of zero point 0.5. Correlation provides a standardized measure, making it easier to interrupt and compare across different pair of variables. Now, I'll give one example to solve how to solve a joint probability distribution of two variable and how to verify the expectation value and standard deviation value, a covariance and a correlation. The question is, the joint probability distribution of two variables x and y is as follows. The table gives the value of x and y. Here the x values are -4, 2 and 7 and the y values are 1, 5. The 1 by 8, 1 by 4, 1 by 8 and the 1 by 4, 1 by 8, 1 by 8 represents the joint probability distribution values. That is 1 by 8 refers to J11, 1 by 4 refers to J12, 1 by 8 refers to J13, and 1 by 4 refers to J21, 1 by 8 refers to J22, and 1 by 8 refers to J1 1 by 8, that is J23. And we have to compute or we have to verify the expectation value, that is E of x and E of y, and the expectation value, the combination of E of x comma y and the standard deviation of x and y and the covariance of x comma y and the relation of x and y. Here, to solve this problem, first we have to find the marginal distribution values. That is, the marginal distributions of values x and y are solved these as follow. To solve this, the distribution is obtained. How? The table is obtained by adding all the two respective rows entries and also the respective column entries. That is, we are adding 1 by 8 plus 1 by 4 or 1 by 4 plus 1 by 8 and 1 by 8 plus 1 by 8. And next, the 1 by 4 plus 1 by 4 and 1 by that type, we have to add the both marginal and the column values. Here, by adding all these respective rows entries and the column entries, we will get a value for a x marginal. The marginal distribution of x is 1 by 8 plus 1 by 4 plus 1 by 8 gives 1 by 2, and 1 by 4 plus 1 by 8 plus 1 by 8 gives the value of 1 by t. This is called as f of xi, the marginal distribution value. And for y, we call the marginal distribution of g of yj. 1 by 8 plus 1 by 4 gives the 3 by 8. 1 by 4 plus 1 by 8 gives 3 by 8. And also 1 by 8 plus 1 by 8 gives the value of 1 by 4. This is the marginal distribution value. To find the expectation value of x and y, we have a formula, summation of xi into f of xi. We have a value of x in a first table, that 1 into f of xi, we find it here 1 by 2, 1 by 2. So 1 into 1 by 2 has similar plus 5 into 1 by 2 gives the value of expectation of x, which is equals to 3. In a similar way, we have a formula to find the expectation value of y, that is summation of yi into g of yj. By solving this in a similar method of expectation x, we got a value of expectation of y, which is a 1. So the combination of expectation of x and y, that is e of x comma y, we have a formula summation of xi yj into g of ij. So the j of ij refers to a joint probability distribution, as I showed in the question, the first tabular column that refers to a j of x, j of j of ij is j of 1 1, j of 1 2, j of 1 3 till the j of 2 3. So by applying all the values in a table, we found the value of e of x comma y, which is equals to 1 by 3. And we have to know one thing, that e of x, which is equals to 3, which is also equal to a mu of x. Mu of x is mean of x. Similar way, e of y is equals to mu of y, and e of x comma y is equals to 3 by 2. These are the values we get by solving the expectation value and the marginal value. Now, we solved option A, that is expectation value, and option B, that is a marginal value. And we have to find the standard deviation, that is rho of x square. To find the rho of x square, we have a formula, e of x square minus mu of x square. In this, e of x square is unknown. We have to find the value of e of x square. We have a formula, summation of xi square f of xi. So by substituting all the values in a formula, we get an answer e of x square, which is equals to 13. In a similar way, we are applying a server, that rho of y square is equals to, we have a formula, e of y square minus mu of y square. Here, e of y square is unknown. So we have a formula to find the e of y square, that is summation of yj square into g of yj. By substituting the values for the given formula, we get the value for the rho of y square, which is equals to 79 by 4. So we got the answer for the e of x square and e of y square. By substituting the values of e of x square in a formula of rho of x square, that is e of x square is, we got the value 13. So substituting a value of 13 to a e of x square minus mu of x square. As I said earlier, that f of x square is equals to a mu of x. So by substituting the value of mu of x, that is a 3 whole square, we get the value 4 for the rho of x square. They asked a rho of x. So the rho of x square, the square becomes a root while we substitute it into the is equals to side. Then we get the value of rho of x is equals to 2. In a similar way, by substituting the values in a given formula, we get the answer, a rho of y is equals to root of 75 divided by 2. So we just find the standard deviation and standard deviation for both e of x and e of y. And the next, they ask a covariance of x and y. To find the covariance of x and y, we have a formula, e of xy minus mu of x into mu of y. We have the answer for e of x comma y, that is the expectation of x and y, that is 3 by 2, as we solved in a earlier. minus mu of x into mu of y, that is 3 into 1. We got the value for the covariance of x and y is equals to minus 3 by 2, whether it may be in a negative value or a positive value. There is no such things. And that is a covariance of x and y. And the last is covariance of x, the as we solved the covariance of x and y. Now the correlations of x and y, we have a formula that is covariance of x comma y divided by standard deviations, that is rho of x into rho of y. As we got the answer for the covariance of x and y here, that is minus 3 by 2 divided by rho of x, here we have a value for rho of x, that is 2, we substituting here, and rho of y is root of 75 divided by 2. So the after the simplifying, we get the answer for the covariance of, and sorry, correlationship of x and y is minus 0.1732. This is how we can solve the joint probability distribution and the expectation values, correlation, covariance, and the joint probability distribution. This is about my topic, and thank you for watching. Keep subscribing my channel and keep supporting. Don't forget to like my video. Thank you.